Okay, welcome to another GINGER Mathematician video. The videos are coming thick and fast at the moment. Again, if you like my content, please subscribe, please click that bell button to get notifications when another video comes out. Your support's really appreciated. Feel free to put the appreciation in the comments or any other video you want me to do. Right, we're going to look at questions 10 and 11, a bit easier than the previous paper 4 video that we did. So we have a probability question. Trisha's got 2 bags. In the first bag, we have 6 white balls, 4 red balls. In the second bag, 4 blue balls, 3 white and 2 red. She takes a ball out at random out of the first bag, then takes a ball at random out of the second bag. So there is no replacement. It is with replacement, i.e. there's no change in probability between bags 1 and 2. So it stays as is. And we need to complete the tree diagram for 2 marks. So if we take our first bag, the number of white balls, there are 6, and we have 10 balls in this bag in total, so this will be 6 out of 10, and then for the probability of red, there will be 4 red balls out of 10 as well. Now we have a completely different bag. So for the second bag, there are 4 blue balls, so it'll be 4, and then how many balls are there in this bag? Well, let's be careful. 4 plus 3 plus 2 is equal to 9, so we get 4 out of 9. Likewise, for white, we have 3 out of 9, and then for red, we have 2 out of 9. And notice it'll be the same regardless of whether we chose white or red beforehand, it will still be the same probabilities. So 4 out of 9, we have 3 out of 9, and finally here, 2 out of 9. Nice for 2 marks, certainly that's marks you should be picking up in this paper for exam. Now they ask you some probability questions linked to this. So first of all, we want to work out the probability that Trisha's 2 balls are both white. So let's go back. So we want the probability of white, the way I tend to write it. And the way we do this is we take the probability of the first one being white, that's 6 over 10, and then we multiply along the branches. So we multiply this by 3 over 9. And remember, to multiply fractions, we times the top, so 6 times 3 is 18. And then 10 times 9 is equal to 90. And we should simplify at the end if we can. I'll leave this there for a future calculation. Generally speaking, on iGCSE Cambridge, they don't mind if you leave it like this, but we should try and simplify it. And if we divide top and bottom by 9, we get then 2 out of 10. Bottom should be 10 and not 9 because we're dividing by 9, top and bottoms. Just to show you what we did there, we divide by 9 here and we divide by 9 here. And then we get to our answer of 1 over 5. But I'll just show you the mark scheme here quickly. So notice if you leave it as 18 over 90 on this exam, or OE, or equivalent, that's absolutely fine. You get your 1 method mark for 6/10 times 3/9. That's wrong. It should be 9 here, not 10. So a mistake in the mark scheme, but that's fine. We know what we're doing. 18 out of 90, so we need to write that. So writing the working, 6 over 10 times 3 over 9, that gives you 18 over 90. Notice that's all I need to write. Now for this one we need to be slightly careful. We need 1 white and 1 red, so that can be either way round. This is important. So we want the probability of red, white, plus the probability of probability of white, red. There we are. Let's not get those mixed up. So let's go back. So the probability of white, red. So let's do this one first. Well, that's going to be 6/10 times 2/9. Notice I'm not going to simplify at this point, so 12 over 90. And then we work out the probability of red, white. So red, white. No reds, just reds. So we get 4/10 times 3/9. There we go. And we also get 12/90. And so we want to use these two answers here. I mean, I would usually write this working on the other page, but I'm working between two slides. So our answer is 12/90 plus 12/90 is equal to 24/90. Now I know with the mark scheme I can leave it like this. Kind of different to what they teach you in year 7, 8 and 9. You always simplify whenever you get the opportunity. Tree diagrams is one of the few exceptions to that. So we get 24/90. Biggest mistake made on this question is you don't take into account both ways round. So you need to do white, red and red, white. I'll quickly show you the mark scheme here. Okay, so 24/90 is fine. Now part 3, we want to make this as easy as possible for us. So we want to work out the probability that they're different colours. So notice you can either have two balls that are different colours or the same colour. Okay, it's one or the other. And all probabilities have to add up to 1. So a quicker way of doing this question, rather than working out everything individually, is doing 1 minus the probability of the same colour. Because whatever we're left with after we work out the probability of same colour is that it must be different colours. The reason I do it this way is that we've already worked out some of these things. So we've already worked out the probability of both white, which is 18/90. So all we now need to do is work out the probability of red, red and blue, blue, I think the other colour was. Yeah, blue, blue, exactly. And then we can just work it out from there. So what I'm going to do is just work out the same colour. In fact, it's even easier than that because we only have blue in the second ball, not the first ball. So all we need to do then is actually work out the probability of red, red, which if we times these two fractions together, we get 8/90. And that's the only way we can get two of the same colour, probability of white, white or red, red. Okay, so I'm going to bring that over, this answer here, minus 8/90. Now, remember, 1 on its own is 90/90. This is why I did not simplify to make the subtracting fractions much easier. And then if I do this calculation, well, 90 minus 18, well, that's going to be equal to 72. 72 minus 8, well, that's going to be equal to 64/90, yeah? Which, as we saw in the previous mark scheme, not need to be simplified. So I'm going to leave it as 64/90. And there's our answer there. So one thing I want to mention with this question is don't always think you have to do things in always the same way. Look for opportunities to save yourself time. And this is a good opportunity. Think, of different colours. Well, if I work out the probability of things being the same colour and do 1 minus that, I will get the answer much, much more quickly. Okay, and you'll see the actual exams report actually mentions this. So the probability of different colours was a little more challenging, but well answered by many candidates because they took this longer method of working out white, red, red, white, red, blue, blue, red, blue, white, white, blue, and added them all together. Whereas if you use the more efficient method, like I've just mentioned here, you'll find that's much, much more quick. Okay, so particularly in an exam which is 2 hours, 15 minutes long, you want to look for ways to make your calculations more efficient, and this is one possible way. But notice this question is generally well answered, so you need to be getting all the marks here to make sure you're heading for those top grades. Right, question 11 is a GDC question. So we have a function and they want us to sketch a graph. So this kind of question, on core or extended, it's just checking you know your graphical calculator. So always notice the scale they give you. So -6 to 4, -12 to 12. So let's do this. I'm going to try and do this side by side. So I have my graph here. Hopefully you can see it okay. It's a little bit on the small side. So I'm going to draw this now on my GDC. So I'll go on, new, graph, and I'm going to write this function into my calculator. So you press Control and divide to give yourself a fraction. 1 minus 2x on the bottom, x plus 3 on top, x plus 3 on the bottom. We get a function, but it doesn't look like what we need to draw. So this is important. We need to make sure the scale is correct. So we want to scale. So we go to Menu, Window Zoom, Window Settings. We want x to go between -6 and 4. And then we want the y-axis to go between -12 and a +12. And when we sketch this, there's one other thing we need to be very careful of. So here we are here. So this is our graph. One thing to notice is we don't actually cross the origin. So when we draw our sketch, which I'm going to do now, where you're going to lose a mark, if you're not careful, is that you go through the origin, 0, 0, but it's a little bit above that. It's actually a third, but which we'll look at later. So when we draw this, we want to make sure we don't go through. Okay, we're going to try that again because that's not smooth. But I'm just trying to show you, people at home, okay, we don't quite go through the origin, but we still keep going down towards an asymptote, which we're going to find a bit later on. And then we've got our graph here, like so. So you get 1 mark for the general shape. Let's look at the mark scheme. So you get 1 mark for the basic shape. You get an accuracy mark for the right hand cutting both axes, so cutting here and here. And then the asymptotes don't overlap, so this shouldn't overlap here. Let's look at our diagram. Okay, mine is slightly overlapping, so we're going to do that again. So make sure that when we draw, it needs to go through. I know it's a third, but then our asymptotes do not overlap, yeah? So there's a clear gap between the two graphs. So we have to be very, very careful when we do this to make sure we get all 3 marks. And now we need to find the asymptotes of the graph. So what an asymptote is, in German you say Ernährungslinie, a linear. So it's basically a line that the graph never, ever, ever touches. Now, in this case, it's going to be this line for our x line, x equals, because it's a vertical line. And then I've used a different color. This is going to be our y asymptote because it goes in a horizontal direction, like so. And we need to find the equations of both of those. Now the x asymptote is the easier one to work out, so let's start with the x asymptote. The way we do this is we set the bottom of our fraction to 0. So set denominator, we'll put denom to 0. Okay, that's the way we find the x asymptote. So we take the denominator, x plus 3, make it equal to 0, and therefore solve this, which gives you x equals -3. So x equals -3 will be one such asymptote. So that's the x one done. So this point here is going to be -3, sorry. And the y one's a little bit more tricky to work out. So I'm going to use a little bit of limit notation here, which we don't tend to do much at iGCSE. I want you to imagine that x gets infinitely big. Okay, so as x goes to infinity. Okay, so have a think about that. Give yourself 10 seconds. If x goes to infinity, how important is this 1 here or 3? So have a think about that while I take a sip of tea. Well, not very important at all. Imagine x was, say, 10,000. If you do, on the bottom, 10,000 plus 3, 10,003, adding the extra 3 makes very, very little difference, yeah? It's what we call negligible. So when x goes towards infinity, the numbers themselves become not important at all. So what happens is the 1 disappears and we're just focusing on our 2x, the minus 2x, and the 3 disappears and we're just focusing on the x. And if we simplify that, the minus 2x over x, well, the x's simplify and we left with minus 2. So our y asymptote is going to be at y equals minus 2, which is this green line here. Make sure if you don't understand the concept there of working out x and y asymptotes, because this is an area that's not sort of well learnt by pupils, just rewind the video, go back, watch it again and go, okay, do I get it now? And try and practice some other questions as well. I'll be doing more paper 4s in the future, so by all means then when I do go through this again, because it always comes up, almost always, on a paper 4, then I will go through it again and hopefully with a better understanding next time. Now the next part of the question looks complicated. Oh, we've got the range of values first, then we've got the so-called complicated part. What it wants you to do here is work out the range of values for y when x is greater than 0. So remember, the word range means what y can be. What is y allowed to be? So let's go back to my previous diagram. This is x is greater than or equal to 0. So x is greater than or equal to 0 is basically this range here. So within this range and off to infinity, what is x allowed to be? Well, let's actually kind of shade in exactly what it's allowed to be. Well, this is the maximum point here, which we'll work out in a moment. We have an asymptote. So it never goes below that asymptote that we just worked out. So essentially, the function only lies within this range. Now we just need to find the dimensions of that range, so the height of the rectangle, if you will. Now we already know this one, okay, so it never goes below minus 2, because that comes from what we worked out before. We just need to work out what this is, okay. So essentially it's our y-intercept, okay, of that graph that we drew. Now we can work that out by using a button called trace. So I'm going to go to menu, analyze graph, trace, graph trace, and you can see you draw like there's a little thing on here which you can move around, yeah? You can move around like this. It's how the old TI and Spire calculators used to work. And what we're going to do is going to keep going until I hit on the y-intercept, which usually it pops up y-intercept, which is very useful, and we'll notice the y-intercept is 0.33333, which is a third. So our y-intercept, if I go back, is equal to 1 over 3. So our range of values that we can have when x is greater than 0 in this purple box I've drawn in is between minus 2 and a third. Okay, we have to be a bit careful with our inequality symbols, which we'll talk about now. So let's fill in that it goes between a third and minus 2. Now notice it can be a third, it can actually touch a third. So this is where we need to put this symbol in. But notice it never actually reaches minus 2. It gets very, very close, but it reaches. So we just have to put in the inequality symbol here. Okay, I just want to show you the mark scheme here. So it writes it the other way round. Okay, I put it the wrong way round because, yeah, the lowest number needs to be first. Apologies. That's silly. Right, there we are, minus 2 and 1/3. Okay, but then we need to be careful of our inequality symbols at this point. It needs to be the other way round. That's annoying. Okay, so you'll notice it's the other way round because it never reaches minus 2. But it does reach a third. Okay, so we just need the inequality that represents that purple rectangle that we created. It never reaches the asymptote, which is this part here, but it does reach that y-intercept which we worked out. So a little bit tricky, You have to think about what does range mean, what y can be, okay, and what range of values can y go between. So we're looking at the height of our rectangle, and then we write the correct inequality symbols there as well. Okay, and on to the slightly tricky question at the end. Notice we get the same function here, just with a modulus sign in. Now, you could do this manually by bouncing it, so to speak, off the x-axis, but we can just use our GDC. So I'm going to show you now this power of the GDC to do this. So if we click on here, we press the tab button, which is this button here, click upwards, and we can see here's our function. What we can do is actually put this in within a modulus. Now, where we find this button, so this is good to be aware of for any modulus style questions, next to 9, this button here, and we want to use this modulus button here. So we click on that. We're going to, well, I can do this copy and paste. Okay, thought I could copy and paste it. I'm going to have to type it again. That's fine. So control divide, and then we type in 1 minus 2x, and we'll type in x plus 3 on the bottom. And you'll see you get almost identical graph, particularly on the right-hand side. Notice what happens on the left-hand side that actually stays above the x-axis. It has this sort of bouncing effect when you do the modulus. So this is our graph here. We've got the same scale, so you should always check the scale, and simply we now draw it, remembering that we are not going to go through the origin. So we draw this graph like so. Try and draw it as accurately as possible. There's still the asymptote. We still cross at a third, but this time we're going to bounce off, and then we go in this direction here. Okay, so key things to remember when we're drawing this: we're still going to go through here, not the origin. We bounce, and then we continue in that direction. Okay, I'll show you the mark scheme here. Correct shape, and then B1 for reflection idea, so a reflection of this part of the graph. And now I want you to solve this, and on first thoughts you go, I've never learned this in class, how to solve a modulus rational function, but basically what it wants you to do is solve it when it's equal to 6. This is a standard kind of question you need to get used to, so all we do is just press the tab button, press 6, so we're going to create a new function at 6, and notice it crosses the graph at 2 points, crosses here and here, and all it wants you to do for the x value is work out what this is. So to find the intersection point, we go to menu, we go to analyze graph, we go to intersection, we click before the intersection point, we click afterwards, and we have a value of minus 2.125. So let's write that in as our first value. These are really 3 marks to get if you know your GDC. So that's the first one, round it to minus 2.13 to 3 significant figures. And the next one, menu, analyze graph, intersection, click before, click afterwards, minus 4.75. And there we are, and we're done. And the mark scheme, those are the 2 answers. No more to do than that, because 2 marks, 2 answers, there's no working their marks to get. Okay, let's just look at the mark scheme. I think we talked about it as we went through. In terms of the examiner's report, most people found the vertical one for the asymptotes, which is fine. It's an easier method, but it's a bit tricky to find that horizontal, so make sure you go over that. The range of function was a difficult topic, and this was no exception. And to give that correct inequality, you can see there's a few things to consider. Surprised it's that difficult, but from my experience, pupils have had difficulty with domain and range in the past. And yep, some people use the sketch in part A or just use their graphics calculator. And it's good to see that E is well answered, so just creating that line. And it didn't give that required accuracy for the 3 significant figures rule. Will apply unless otherwise stated. I've mentioned that before in previous videos. Always round to 3 significant figures. Alright, we've got one more question left on this paper. I will leave until the next video. Again, please like, please subscribe. It does really help the channel grow. and it helps me to create more content, hopefully a bit more paper 4. See you next time.